Started then. All right. So this is the summer Stella webinar with Brent Yantis here and the RAC team. I should introduce myself, and I am Mike Taylor with the Landsat Communications and Public Engagement team, and I'm also the Stella team lead, and we are proud to have Brent and the RAC team here to talk about their stuff. I should also mention that Stella is basically, at this moment, it's a few different instruments. Today, I believe we'll be just talking about the spectrometer. It was developed under Landsat at Goddard. It's a modular, accessible, low-cost instrumentation that is a nice outreach and education tool. So with that, it is solely an educational and outreach tool designed to help students and the community learn about Landsat and remote sensing. The performance of Stella has not been scientifically peer-reviewed, and data retrieved should be used for educational purposes only. Okay, and today's panel, like I said, is the RAC team, the Regional Application Center team at the University of Louisiana at Lafayette, under Brent Yantis, who you see here, and they have been doing some amazing work. I should also mention that Brent Yantis is part of America View, which is all about Earth observation, education, nationwide. And I have talked to many of the folks there at America View, and they're all fantastic, and I've worked with many of them as well. Okay, so with that, Brent, it's all yours.
All right, great. Thank you, Mike. I appreciate it very much. And we'll go ahead at this time and go ahead and welcome everybody into our classroom here at the university. And so we're located in the research park. And so as part of that, this is where we host a lot of our GIS, geospatial, and remote sensing training for our students. And so what you'll hear today is from a lot of those undergraduate students who are part of the program who've been part of this project. So again, welcome everybody into South Louisiana. We appreciate you being part of this. And we want to thank very much Mike, Paul, and the Stella team for the work that they have done in regards to this and the want to collaborate with us in a way that we were able to gain off of all the work that they've done for the Stella program. You know, our relationship began a long time ago because the RAC, or Regional Application Center, was actually established in 1997 by Goddard. Okay, we are one of the first 4 original RAC centers that were put together underneath that program. And so through that, we've tried to expand all the different things that we do here in our education and outreach. And so with that, we have worked with Mike, we've worked with Ginger Butcher. And so Ginger, appreciate if you're part of this and whatever else today, the work that you have put out there and the ability to work with you. We had a great time. This is one of the first times I got the chance to work with Michael, and that was at the launch of Landsat 9 in 2021 over in Lompoc, California. And so we did a lot of education outreach for over 2,000 people that morning of the launch. And so that was great. We've had other opportunities to work with Ginger, with Mike, with the teams in regards to a lot of these different education outreach programs, including the last PCORA conference that was done up in Denver. And so we had a great time with that. And so we appreciate those opportunities. So what we try to do here is bring a lot of that back into the classroom and into our programs. And so with that, we have a program that we're working on funding under the National Science Foundation, which is part of our GeoPaths program. And in that, it actually envelops all of our outreach that we do. And we developed a summer workshop called Rising Water as part of that program. And so in that, we try to bring in 8th grade through 12th grade students in the summer to be part of that program in Earth observation. And so as part of that, we have a team of, I guess it's about 10 students that are actually on the grant with us who actually work on development of outreach activities for that summer workshop. And when we were introduced into the Stella program, we thought that's going to be a great hands-on opportunity to familiarize these students with the technology that goes on with these sensors, and then allows us the ability to then relate that back up the scale to things like the Landsat program and the sensors there. And so having that hands-on, which you'll see today as our students come forward to talk about this, has been a really great program. All of this has been done based off of what we've learned over the past 3 years of conducting these summer outreach workshops with these students. And so with that, Dr. Courtney Poirier-Chicola has joined our team here after many years working with us on all these things. And so I've let Courtney kind of take the lead and be the spearhead for this for the undergraduate students as they've moved forward with their work that they're doing. And then we bring about all this to our summer workshop, of which I'll put a plug in and say that our third summer workshop is about to occur starting next Monday. And so we will have all this in play with that program. And so with that, at this point in time, I'm going to go ahead and turn everything over to Courtney. And so that Dr. Chicola can go ahead and handle the whole rest of the exercise. I'll be back at the end to answer any questions that anybody might have, along with the entire student team. So with that, I'm going to turn it over.
Hi, once again, my name is Dr. Courtney, and here is kind of the outline of our presentation. So all in all, we are going to showcase how STELLA can support Earth observation outreach through different kind of components. So one thing is integrating the use of STELLA into our summer workshop program activities and developing interactive Kahoot games for STELLA and Landsat, along with our STELLA and engineering component, where we'll have our engineering team come up and kind of show you different ways that we came about from STELLA and what kind of components we were able to develop because of our use of STELLA. So before I get too far ahead, I would like to acknowledge all of the people that are part of this tremendous team. Here you see all the undergraduate students, along with the faculty advisors and staff, and all of the supporting organizations. So all of this is possible because of an NSF-funded project in the GeoPads program. And then with all the help from Mike and Paul with the STELLA team, allowing us to borrow these STELLA units as loaners and kind of get to play with them and see what kind of programs that we can develop from that. So these are the faces behind the names, and you will get to see some of these students talk today, giving their experience and their takeaways from utilizing STELLA in the development of our educational outreach activities for our summer workshop program. Before we jump too far ahead, I'm going to give some background information. So kind of like what Mike iterated earlier, these STELLA devices provide an entry point to help better understand the sensors on satellites, including the electromagnetic spectrum. Also, these students are able to learn how to collect spectral data and create spectral signatures, and to overall help interpret data while highlighting the importance of Landsat satellite imagery. STELLA is designed as an educational and outreach tool to teach about Landsat and remote sensing to students and the community at large. And Landsat plays a crucial role in this, including the upcoming Landsat Next, in these educational outreach incentives and kind of the program materials on which the knowledge base is developed. So what are we known for at the RAC and as part of the Louisiana View in the greater scheme of America View is our Traveling Earth as Art Gallery exhibit. So some of these images here are satellite images. And so they're really pretty, but they're more than just a pretty picture. So in the first image, we can see some ancient river channels in Kenya and their refugee camps. In the middle, we see the Mississippi River Delta. And on the right image, we see the Colima volcano in Mexico. So these different colors that are represented in each of these images tells a spectral story. So either highlighting urbanization, land loss, deforestation, what have you, these images help tell that story. And so it's all possible because of spectral data collected from these sensors. So focusing on the Landsat program, it's a series of Earth observing satellite missions. The current resolution is 30 meters, and there's a multitude of spectral bands corresponding to the electromagnetic spectrum. It is the longest continuous collection of land remote sensing data acquired from space at a moderate resolution. And we have seen the Landsat program, the data collected from it, applied in all things research, business, education, and much more. And in our case, we like to use it as art. But building on that 50 plus years of Landsat legacy, this is all possible by the public's engagement and awareness of what Landsat has to offer. So with that, we are awaiting the newest arrival of the Landsat Next, which is expected to launch in late 2030, early 2031. And this one's going to be a unique kind of constellation aside from what previously Landsat satellites were made of. This one's going to be a constellation of 3 satellites, and it'll be able to aid in the current temporal revisit that we currently have, which the Landsat 8 and 9 is on a 16, each on a 16-day repeat. Whereas now with this new architecture, we're going to have 6-day temporal revisits. And so this will be able to improve cloud-free scene acquisition and also enhance our monitoring and management capability of this dynamic and changing landscape of Earth. So examples include vegetation and crop monitoring, water use and evapotranspiration, early detection for wildfires and algal blooms, monitoring public health during disasters such as massive heat waves during the summer, and then tracking the dynamics of snow and ice on both land and sea, especially with our component for rising water. That is one of the things that we like to highlight in our theme for our summer workshop is rising water. Being in coastal Louisiana, you know, it's a big issue and a lot of it stems from glacial melt. So we like to see what kind of things we can pull from there. So with that, I'm going to turn it over to our education and outreach team, and they will give you some insight on our program activities within our summer workshop.
So our Rising Water Summer Workshop is a week-long workshop that aims to introduce STEM career paths to 8th through 12th grade students with a focus of Earth observation of contributing factors and effects of rising water. So during this workshop, our students participate in a NASA USGS river sport game, a NASA kite flying, drone demonstration and flying, Earth as art exhibit, and our floor puzzle, which is also a competition, our stream tables demonstration and hydrology, which highlight water systems. We train our students in thermal readers and spectrometers, and we have a change detection memory game, which is another competition we do with our students. And on our first day of the workshop, our students are introduced to 4 topics. There are glaciers, engineering, coastal communities, and coastal vegetation. At the end of our first day, the student picks one topic, and throughout the workshop, the student focuses on that one and obtains knowledge from the activities that we do. And on our last day, with mentor help, the students develop their own story map and present it to the whole workshop. And we're going to talk about our thermal readers and spectrometers that we're currently using now and how we plan to incorporate STELLA this year. We use a portable thermometer for our students to go out into the field and take measurements of thermal radiation emitted from surfaces in either Celsius or Fahrenheit. These are very portable. They can take it out right into the field here in downtown Lafayette. We are currently using these in our Urban Heat Island project. And whenever our students go out to the field, they have these worksheets to work with. They record their data. We go several times throughout the day. We have several different surfaces that our students check. And also, we always want to remind our students that we make sure which degree that we're working with, Celsius or Fahrenheit. We also use the Alta 2 reflectance spectrometer. It's an active remote sensing sensor that collects spectral data reflected from different surfaces and objects. It uses 11 different bands that are part of the electromagnetic spectrum. And here we have images that we've taken in the past of our workshop, students actually working with these devices. You can see here we're downtown Lafayette. We're also working with them in the classroom, recording our data using the worksheets. And our students do have to do some calculations. We use this calculating reflectant worksheet to record the dark voltage, the light wavelength of the sample, standard white paper, and the percentage of reflectance. And using that worksheet, our students plot onto this graphing reflectance using their light and wavelength reflectance. So this is a process, but here is how we are planning on to use the STELLA and we've practiced with the loaner STELLAs that we've received.
So one of the ways to improve our workshop this year is by introducing the STELLA unit, which allows us to combine these two previous devices into one. So STELLA stands for Science and Technology, Education, Land Life Assessment, which was created by the NASA Landsat Science Outreach Program. So STELLA essentially measures the surface temperature, humidity, altitude, barometric pressure, and reflectance across the visual and near infrared portions of the wavelength spectrum, which is what our spectral spectrometer does in our summer workshop. And the STELLA also provides an optional height measurement data using LiDAR detection. And STELLA is an educational and outreach tool that is used to teach about Landsat and remote sensing to students who participate in our summer workshops and the community. So NASA loaned us 6 STELLA 1.1 units. And what we did was we had our mentors learn how to use the device, and we took it out into the field. We took data measurements like how we would do in our summer workshop. But the great thing about STELLA is that this device is a 2-in-1 device. And it also collects data so you don't have to handwrite your data on your worksheets like before. So we had our mentors go out into the field, take their measurements, and then we had them go into our computer lab and view the data on the NASA STELLA Data Viewer website, which is very useful because it'll show you all your data without having to record it handwritten. And from there, we took the STELLA activities that were created by NASA and are publicly available, and we decided to use them as a template for our urban heat island activity, which we will be using in the summer workshop to teach students about how urban and rural areas have temperature differences. And from here, I'm going to lend over this to the urban heat island team.
So I've been a part of this urban heat island project that's very similar to the one that we do at the workshop. Instead, we do it prior to the workshop with the goal of collecting surface temperature data so that we can use it to introduce one of the main factors that contribute to urban heat islands, which is land use type. Me and 4 other wonderful undergraduate students have collected data for the past month at 3 different sites. And we measure 4 different surface types: concrete, asphalt, grass, and soil, 3 days a week at 9 a.m., noon, and 4 p.m. This usually takes approximately an hour to get all these measurements and return back to the RAC. So we're looking at 3 hours of data collection per day. Then once we have all this data, we transfer it from the paper sheets onto Excel, which is very time consuming. Then once we have this data, we can put it into Excel and make some of these charts that you see here. And here's just a closer look at one of them. On our x-axis, we have the times that we took the samples, 9 a.m., noon, and 4 p.m. And on our y-axis is the temperatures that we recorded for that surface at those times. We can see asphalt in red, concrete in blue, grass in yellow, soil in green. And what we could do is show them how these different surface types change over the day, and how concrete and asphalt, these impervious surfaces that cover most of the urban areas, heat up the most. And with the STELLA, we save a lot of time doing, we combine these devices together. And so you can take one sample and get the temperatures that you need, the reflectance percentages all together. Also, it prevents me, whenever I'm having to transfer that data, from having to wait on responses from people with bad handwriting, and I have to wait to track them down and put that data into it. And as for the reflectance data, instead of having to do all of that math, make this chart, the NASA's STELLA data viewer makes that chart for us and can display what we need. Another good thing about having the STELLA is having all this information on a computer. It's cloud-based, and we can't lose it nearly as easy as we can lose a sheet of paper. So we see how much better the STELLA, or collecting data with the STELLA, is, rather than using both devices and paper. Now that we've discussed the advantages of using STELLA for this, I'm going to turn it over to our education outreach team.
All right. So a big thing that we've noticed is that the STELLA unit provides a different learning experience and interest levels across different schools, those school levels. And so with your grade school and junior high students, that we had discovered in our summer workshop was that the younger students were more science interested. They had low mechanical and electrical aptitude, a little understanding of data being captured, and they just want to see the end result as quickly as possible. And then with our high school students, we had noticed that they were more interested with engineering and science. They had a higher potential of their aptitudes. They had a greater understanding of what the project is and why we're doing it. And they wanted to be hands-on, a part of the process in getting to our end goal. And were even more interested in how we got there instead of the end result. And so we kind of wanted to make it to where our junior high and high school students would understand it at the same level. And so we used a software called Kahoot. And with Kahoot, we had engaged our students in the summer workshop more and more with each other and us, and kind of broke them out of their shell. And we wanted to use Kahoot because we noticed in our surveys that a lot of the students rather engage with each other, engage with the mentors, and just be engaged as a whole rather than sit in a lecture. And so with Kahoot, there are many different ways to get our students engaged in the educational lessons. That top photo right there is 14 different ways that you can present your educational lessons. And then at the bottom is media and text, which are different ways you can present your lessons. And the main goal here is that students plus STELLA plus Kahoot equals increased STEM engagement overall.
So we are really using Kahoot to teach students the information we want to show them throughout the workshop interactively. We've seen through our data that the students really do enjoy Kahoots for things like icebreakers. Kahoots have been used by other people too, as they were used by the National Wildlife Foundation for their Ranger Rick program. Some of our interactive Kahoots include topics like STELLA, Landsat, and Earth observation. The STELLA Kahoot information comes directly from the STELLA tutorial, and the Landsat Kahoot information comes directly from the Landsat website. And now I'm going to turn it over to the engineering team.
Our engineering team was made in conjunction with the creation of our 3D printing lab. We did this because of STELLA's DIY capabilities, in realizing that both undergrads and high school students could benefit from learning these skills because it is used as an educational tool in our workshops and hopefully as intended for other schools around the country. we developed a program where we would learn how to 3D print by making these smaller models and tokens that you can see on the bottom of the screen for game pieces or tokens for a workshop to help practice and work on our technical skills. These tokens, while related to what topics we cover in the workshop, are used in our Rivers game that was made in partnership with NASA and USGS. We workshopped the game in our summer workshop several times, and we've seen a pretty good result from it. And each student can put input into what kind of pieces they want, and the students can look at them and play with them, and then get to take a couple home at the end of the workshop to highlight and promote an interest in 3D printing skills for the future.
Okay, and so by us being involved with STELLA, not only our students will be able to learn a lot from it, but also us as mentors have learned so much from being involved with it, because a STELLA is consisted of a lot of different moving parts. Well, not moving, but you know what I'm saying. And so 3D printing is required for the encasements. And so we have perfected 3D printing by making little trinkets for our summer workshop. And then we have learned how to actually make more improved models from that and to get higher quality in preparation for our Stellas. And so we have been doing a lot of informal learning through this, like during this process, by one of our peer mentors, because he had prior experience with a lot of this different things. So he was teaching us, and so students teaching students. And so we have acquired all of this knowledge, and that we'll be able to teach a little bit to the students in our workshop. So in the bottom left picture, you can see us disassembling the hot end of the printer, because printer maintenance is very important, especially when you want to get a good model like we wanted with the Stellas. And then in the middle bottom picture, you can see me soldering for the STELLA electrical components, because nothing will work if you don't do it right. And in the bottom right picture, you can see some of us learning how to properly solder in preparation for soldering our STELLA. And then in the top right, you can see us learning about 3D modeling. And so this is our STELLA that we have here at the RAC. And you can see all the components there. And so the students, we believe, will have a blast with this at our workshop next week. And now I'll turn it over to Dr. Courtney for the concluding remarks.
So now that you got to hear from our STELLA team here at the RAC, just to summarize it all together. So we've learned that STELLA brings the foundational space-based measurements of spectral data down to earth and in the hands of students. And these students are able to become their own citizen scientists, making spectral measurements wherever they are. Ultimately, STELLA is able to engage students with remote sensing, allowing them to explore key concepts, explain their understanding through practical application, elaborate on their knowledge with real-world data, and evaluate their learning process through hands-on technology. And once again, this was not possible without all of these people here working so hard on the project, along with our supporting agencies who have supported our programs, such as the America View program, the NSF-funded grant that we were able to do all this work, the NASA STELLA team, along with USGS. And with that, thank you, and we will take any questions. But first, I will leave this up here for those who are interested in learning more about what we do and different components that we have for our summer workshop programs. So here I have contact information and also a QR code. If you're interested in scanning it, it would take you directly to our website, which is also shown below. Thank you.
All right, thank you very much. That was great. Yeah, so are there any questions from the attendees? If so, please post them into the chat. How will you document this for others to use? Is the question from Rebecca Dodge.
So basically, we're recording everything that we're doing, and We've actually written some different documents, tutorials, things like that, that talk about what we're doing with all of this. We've provided a lot of this to Mike, Paul, their team, and we have all that also available at our facility. And we're eagerly going to participate in putting this out to anybody who might be interested. We also will be writing a complete report for the NSF grant, of which the STELLA component will be part of that and what we've done there. But we are documenting everything that we do. We take pictures on everything that we do, from the engineering team to the outreach team to those that are collecting the data and all of those components of working with the STELLA units. And all that is available, and we'll probably be posting every bit of it out on the America View website. So.
Excellent. And now Rusty Lowe asks, I think this is something a bit more specific to me, but will there be further dev to make the data useful for research? Useful to research. And for that, we hope to do further dev to see, again, it does require more scrutiny to make sure that, basically to establish some error bars. So with that, we're trying to do like a classroom calibration sort of a thing. And I've been pushing for that in order to basically, again, make sure that, anyone, anywhere, that makes these and develops these things can hopefully get the same, error bars that the others get. But there's some ideas for that. Another question from Rusty Lowe is, can you tell us more about the AQ version and if it is expected to provide research quality data? I would generally refer to Dr. Anissa Rain for that. I don't know if I haven't used Zoom enough to see if I can get her to answer that question. Let me see if we can bring her into this because I saw her here. Sorry, take one more second. Actually, it looks like she might have departed. Again, so for the AQ version, again, that would be need to undergo more scrutiny. We've had a few different little tests and stuff like that, but we need some actual, we need other people to scrutinize it as well to get it peer reviewed. So all of this stuff needs to be peer reviewed before we can make any kind of claim or before we can call it any kind of research quality data. Now, this is for you all. It looks like, what are the most significant mathematical concepts that you learned from your work with STELLA? I think that's for you and your team.
I would definitely say the reflectance percentage equations were complex.
Reflectance percentage equations. Okay, excellent. From Karen Carker, thank you for this excellent presentation. How many STELLA units did you build and for what size of a group?
Okay, so we have 2 units available, and so we're going to be utilizing those in our workshop to be able to compare the data from the STELLA units compared to the spectrometers and the handheld thermometers.
Yeah, because what we'll have is we have roughly about 25 students, 8th through 12th grade, who come in for the summer workshop. And so our students will be working with them with the data collection in the field. What we're really waiting on as we do all of this is for Mike and them to get forward with that 1.2 version. And that's what we're really wanting to build into a major production, right, Mike? So the students are really eagerly awaiting to kind of move forward with the program. There will be more units that we will be producing because what they're doing is they're learning different techniques and things like that within the units as they produce them. And but we do have the 2 that we'll be working with out into the field.
Excellent. Okay. Can you stop sharing the screen for the moment so we could see the team, by the way? Next question comes from Ginger. How are you promoting inquiry and connecting to Landsat data?
So with that, Ginger and others, basically what we do is that, okay, let's take the summer workshop, for example. It's all about Earth observation. And so what we're doing is we're teaching everything all the way up from playing, as you might see, if she turns the camera just a little bit, you'll see the NASA Aaron kites that are hanging from the ceiling. The students actually go out and fly these as part of the workshop. And it becomes our first level of Earth observation with some of the different instruments that we actually hang and deploy from those units. The next thing we do is we jump into drones and we look at the data collection from a drone perspective. We have on-hands demonstrations that we do as part of the workshop. And then the next thing is that we bring in the STELLA units to actually look at the collection of data, and so that they understand the idea behind the sensors and the spectral program with behind that, with the electromagnetic spectrum and things like that. Rebecca Dodge comes in from Texas View and works with us as we do that with our team, because America View supports all this that we do. And so with that, then they take what they've learned there, and then we take them to the next step. And that is we start looking at the Landsat program, and we start looking at the sensors on Landsat and how we compare that back to everything that they've done up to that point. And then from that, then we're able to go ahead and create the lessons that we do on change detection. Then we created a memory game that's a floor game that you heard mentioned earlier. And so with that, they actually compete against each other during the workshop on this memory game, looking at change detection from the Landsat satellite system collection data sets. And so a lot of this we got from the Texas View program, and we've kind of implemented it into our program to make it an interactive, competitive. I'm into competition in case you can't tell that. And then we do the same thing with bringing in our Earth is Art. We bring in that same sensor data that we're talking about with the Landsat. We create these images. They're 12-foot floor puzzles. And so then the students have to compete against each other in teams on putting their puzzles together. But all the time we're teaching them about this whole component. So we work them up from the elemental scale of what is Earth observation and build them up to what's going on within the satellite sensors themselves. And then we're able to utilize the Landsat data, because as part of the last thing that you heard about at the beginning, when Tiffany was explaining some of the workshop, is that they actually go in and create their own projects. And so they're divided into teams. One's looking at vegetation, one's looking at such as glaciers, ice melt, things like that. Another one is looking at engineering components from that standpoint. And then we're looking at what's that last one? Coastal communities and the impact of all this in regards to, because in Louisiana, with the Gulf Coast, it's not just here with us, but anything along the Gulf Coast, both NASA and US NOAA have identified that we are the most susceptible to sea level rise of anywhere that's coming about within the Gulf. And so how that affects us here is greatly important, because we're actually seeing indigenous populations moving from their indigenous lands along the coast and having to move inland because they're now underwater. So we actually have displacement of human populations. And so what we've done is that we teach the beginnings all year long with our undergraduate students that you see here, and then through our workshops, I try to step out of it, because I try to tell our students I'm still 39, right? But these 8th grade through 12th grade students really relate very well to our undergraduate students. And so then by teaching our undergraduates all of this knowledge, and then they take it and put it in the hands of our high school and 8th through 12th grade students is a better component for transfer of knowledge. And so that's how we try to do that. And so then in the end, they're actually building a story map based on the Landsat data that they downloaded about their different study area that they're looking at, so that they can actually relate to that whole component of Earth observation. So Ginger, I hope that answered your question in regards to, I know that my students can tell me that I can talk for a very long time, and you've worked with me long enough that you know that. So anyway.
You don't talk that long. It's all right. Continue. You had more? No,
No, no, I saw somebody else popped up another question or
yeah,
comment.
there's more questions. Will there be a place where others can model off the important work with their students? And that was from Rusty Lowe, and I think that also ties in with Rebecca Dodge's. Have you considered developing a training set of materials that we could use for outreach? So, training set, and where would you put it, basically?
Okay, yes to all of that. And Mike and I have discussed this. We've sent a lot of data to Mike for NASA's review, because we're not going to put out anything without, you know, NASA and all the programs who are sponsoring this through the STELLA program overseeing those first in regards to. But once we do all that and whatever else, we are definitely we're going to share every bit of it. And so anything that NASA wants to put out there and whatever else is going to be available to anybody who might be interested.
Excellent.
And we're glad to share any of that. If you have questions directly to send, I'm gonna direct everything to Courtney because that's why I hired her on. And so that everything goes to her first. And that's a joke, okay? But she gets a kick out of me putting her in the hot spot. But anyway, so, you know, all that will come in and we'll actually address anything that comes to us. We have no problem with that.
Cool. And then Ginger has a follow-up question asking what tools are they using to do those projects using Landsat data? I heard story maps already. Do you have some other tools?
So one of the tutorials that we actually developed is an Earth Explorer tutorial. So a lot of the Landsat scene data, we download from there, and we teach them all what the different spectral bands mean and how to composite them, and for them to tell like their own story, messing or enhancing the color variations within the image by just changing simple band combinations to highlight either land-water interface or urbanization. So you can mix and match these spectral bands for it to tell the story that you need it to tell.
Very cool. Excellent. All right, let's see if there's any more questions. I haven't seen any more come in at the moment. I did want to make you all aware of, you know, Landsat's aquatic reflectance product and, of course, the stream tool that just came out as well. And I think I sent you links to all that. And, of course, there's, you know, other fun things like RSAT and Worldview, you know, where you can get some fun Earth data as well. And we're doing a workshop coming up using peers as well to get Landsat data. Make sure you don't sleep on HLS data, harmonized Landsat Sentinel data, that is, because you can get some better repeat times with that. And then with that, let me do the thank yous and all that. So let's
Yeah,
see.
and Mike, before you go on to your thank yous and whatever else, I will say that that is some of the components that we are looking at as we talk about some of the aqua sensors and things like that. Because in our summer workshop, we incorporate a whole stream table component. We just got a really nice new one that we put in. And so we try to use that as an interactive tool so that they actually work with some of the stream data components. And then with that, we can actually bring back and look at some of the sensors and stuff as provided by Landsat and others as we look at some of these different types of occurrences.
Yeah, excellent, excellent. And we also have a few teams that are on coastal areas that would be very interested in what you're doing as well. And you might be interested in what they're doing as well, because I know we have a few like looking at red tide and algal blooms, as well as possibly macroplastics in the ocean gyres and all that sort of stuff. So you might be interested in all that. But I do want to thank you all, Brent Yantis and the RAC team, and especially Courtney for having to put up with multiple emails back and forth. It was just, I know it was a lot, but you know, we made it. And I want to thank the STELLA team, Paul Murrell, Dr. Nissa Rain, Dr. Petch Campbell, Jesse Barber, Ross Walter, and Paige Williams. The Landsat project, I want to name especially Ginger Butcher, Chris Nye, Bob Swap, Matthew Pierce. I mean, the list goes on, and I could name people forever. There's just multitudes of folks that are just fantastic in helping make this STELLA project what it is. And
Mike, let me just iterate into that and tell you that my entire student staff here thanks that support, especially from the STELLA team, as they go forward and whatever else. So yeah.
Yeah, it's like I said, this is thank you very much. No, this is an amazing project, and it's just, again, seeing all of the different ideas, pop into people's heads with talking to engineers, scientists, and so on and so forth. It's actually kind of overwhelming at times, the different ideas that people have for using these things, which is fantastic. And again, I do want to highlight the importance of calibration. So one of the things again that we're really looking at is understanding some of the basic concepts of calibration and all that would go a long way, and these can help out with that. So and with that, I'm going to, I guess, almost say goodbye. We'll just talk about the next steps. So refine protocols for calibration. We want to make a data repository for the STELLA data so we can actually see, how they compare and all that at a certain point. Build activities, and it sounds like you all did well on the way with that. And since this is an authentic STEM experience, as Matthew Pierce puts it, I love that you're going through the whole route, the engineering, the science, the education, all that, just learning about all the fun different aspects of STELLA. And we're going to continue updating and innovating, and we definitely want to foster more collaboration. So we'll continue to talk and hopefully send some of your stuff there other folks' way as well, so that you all can collaborate with some others and see what they're doing with STELLA, because I think you would be blown away by some of what they're doing as well. Okay, so with that, again, I will wrap up and call it a webinar. Did you all have any final thoughts before I end the recording and all that?
Our final thought here is that we're looking forward to that 1.2.
Yep, yeah, we're thinking about that too. So it's we'll see. There's some things in the work. I don't want to go into too much detail, but there's some really good possibilities with that coming up. So we'll see. So thanks again, and this is fantastic. And I just can't thank you enough for all that you're doing, and continue the good work. And again, feel free to reach out with me anytime. We want to know what you all want to do with these things, and if we can help you in any way, we want to try to be there for you if we can. So thanks again, and have a good day.
Thanks, Mike.
Thank you.